Good afternoon to everyone, and welcome to the third seminar of the fourth edition of ESIC seminars. Today we are here with Professor Giovanni Besio and Francesco De Leo, and we will explore the maritime and coastal engineering with a particular focus on nature conservation and climate change mitigation in different contexts. To briefly introduce them, they come from the University of Genoa, where they are part of the Meta-Ocean Research Group. That is a research group on environmental fluid dynamics and engineering applications related to meteo and ocean dynamics. And I will leave the stage to them. There will be their two presentations, and then there will be the time for the question and answer sessions. And then there will be a very vivid debate together. Hopefully. So thank you. And I will leave the stage to Professor Giovanni Besio for his presentation.
Okay, thank you, Marta, for the introduction. Okay, thank you very much, first of all, to invite us to give this presentation. Basically, we will speak about coastal stuff, so maybe in Trento is not really usual. Maybe in the next future it will be usual. We will see why. So my first talk is about the context. So I will try to give you some hints about the problem that we need to face in the future, and then Francesco will show you some new approaches and new solutions. So why appetizer? Because basically nature is beginning to serve us what is going to be the main dish for the future. And actually, from the coastal point of view, we had already different appetizers. Let's say that, as we will see, the last year began already the launch. Okay, so we will see what I'm speaking about. Okay, so basically, as any kind of vulnerability, the coastal vulnerability is strongly dependent on the condition, on the forcing condition. And for us, the main drivers basically are the sea level and the wave action. Sea level, basically, we have two contributions, one due to long-term sea level, which is the classical sea level rise that maybe you heard about it. And then there are some fluctuation of the sea level due to storms, due to the presence of waves. So basically, when you have waves, you have a adding forcing. So we need to understand how these two things change and how they are related to climate change. These are some words that now are beginning to be a little bit old, but basically in order to understand the mechanism, they are quite useful. So the first thing is the globe is heating up, and the biggest amount of heating and of CO2 is absorbed by the ocean. And right now we didn't have a really big tipping point because the ocean is a huge reserve of heat and CO2. But first or later, it will begin, and it began, to give it back. Okay, so the first message is everything is heating up. Okay, these are anomalies. Okay, this thing is not really nice. I will put here, which is better. So you see, basically, it's last 100 and more years, and you see that all anomalies everywhere, land, ocean, are just increasing. That means that everything is heating up. On the bottom right, you have the so-called classical CO2 concentration as Mauna Loa observatory, which has been the historical observation of the growth of CO2 concentration in the atmosphere. Okay, so another word show you that with the increasing of temperature, you have an increasing of wave power. So I just give for granted that everybody knows what are ocean waves. If someone doesn't know, please tell me. So the sea is heating up and you have more ocean waves. So this work made a lot of association. You have trends, they are quite clear from the analysis. That means they are the construction of the past and for the measurements. And you have the subdivision on different submasing. You see that the worst is the Southern Ocean, that means close to Antarctica. And the other basin, basically, they are behaving quite similar. So you are heating up the ocean, you get more storm. Why? Because basically the ocean is the fuel for atmospheric storms. If you have more heat in the ocean, you have much more stronger atmospheric storm. For example, this is a problem that we in Liguria, we suffer every autumn. The sea is really warm, so it's like a bomb, and we suffer a lot of floods. The other thing, as we said, is the sea level. And so there is a huge branch of research that is working on sea level rise, and these are some projections. This is one of the most famous work and most precise work that has been out. And you see that usually mid-century, end of century, you see that everywhere in the world, but from some place, you will have increase of the mean sea level. Okay, so in some places you see 2,100, 2 meters. Okay, 2 meters is really a huge quantity. So the other thing is at this projection, because these are future projection, I don't know if you work in climate change, but basically the approach is to make forecasts at the long time. So the question is, are this projection reliable? I mean, what we are seeing for the future, it will happen or not? So I just brought you some comparison. This is the sea level change. And you see that the observation is the orange line, with red at the satellite observation. So orange are physical gauges. And the blue lines with the blue band were the projection developed in the 90s. What does it mean? That actually the world is going worse, faster than what it was forecasted. And basically you can see on the top right is the projection of the extension of the Arctic sea ice. So you see that the projection was that the decrease, but the reality is much faster, the red line. And the other thing is again, the observation of the deviation of the extension of the Antarctic ice. Okay, 2023, as I told you, is the beginning of the launch. I was happy to speak about appetizer, but we are beginning to have the launch. Why? Because 2023, maybe we will see, because there is a lot of people working on it, maybe it trigger a tipping point. A tipping point, I don't know if you know dynamical system, is when you have a bifurcation in the system going one direction that was not forecast. So you see that you have a really strong deviation for Antarctic ice. And Antarctic ice, it is a huge problem for sea level rise, because basically the Arctic is ice made from the sea. So it's just a balance between ice and water. But Antarctic ice, basically you have thousands of meters of ice on land. So when they melt, like Greenland and Antarctic ice, when the ice is melting, it goes in the sea and it adds it up to the water masses. So this is really worrying. That means it's diverging, it's melting much faster rather than what was forecasted. So this is taken from the work of COP that I show you. These are projections for Genoa, just to give you an insight. And these were made with, I don't know if you are confident with the climate change, IPCC reports, with the previous report, this so-called AR5. And basically, we will see that we are going on the RPC 8.5. So it means that by the end of the century, we will have 1.20 meters of sea level rise in Genoa. Last year, IPCC released a new report, which is called the AR6, which takes into account not just the geophysics, but as well the social, economic triggers. Okay, so you have different scenarios. The most optimistic is the blue one. You see, that is the net concentration, where every country is really cooperating and they do a lot of measures, there is no conflict and so on. Actually, the actual geopolitical situation doesn't suggest at all that kind of scenario. The other one are more different. Let's say that we are getting on the red one, which is the worst. That means countries competing without any regulation. And basically, we are setting up on that scenario. And on the red line, on the black line, you see historical emission. So what we are measuring. So we are just going on the red. So if you want to play, you can go on the NASA portal of sea level rise. These are the last results with the new projection. You see that more or less the scenario that we need to look is the SSP5, which are the new scenario that they are named in a different way. And you see that more or less they give you similar results. So an increase of 1.2 meters. This is the long term. Then there is the short term sea level rise, which is connected to waves. When you have a storm, you have wind blowing on the ocean, and you have low pressure. So low pressure allows the sea to increase, the sea level to increase, and wind pile up water against the coast. So you have what is called storm surge. How much could be this? I just give you an example, and this is the appetizer that I was speaking. 2018, so it was 5 years ago, 5 years ago, more or less. You really well know this storm, which is the storm Vaya, and here had a lot of impact, but in the sea, in the Mediterranean Sea and the Adriatic Sea, it gave huge storm surge. So we got the signal from the gauge, which is in the harbor of Genoa, the red signal. We subtracted the astronomic tide, which is the blue signal. So the residual is the contribution due to the storm. So this gauge is protected in the harbor. So basically we had more or less 70 centimeters of piling up due to storm surge. This is exceptional. In Genoa, maybe we have 10, 20 centimeters. And this was in the harbor. When you have waves on the coast, you have non-linear effect, and you have half a meter more. So basically that days, we had more or less 1 meter of storm surge. Okay, so if you remember, means that in those days, we had an anticipation of what could be the future. That means 1 meter of sea level rise. Okay, so standard condition. So what happened? In those days, we got really strong wind from the southeast, Scirocco. We pushed this big storm surge and create big waves. These waves were different because usually in Genoa, we are used from waves coming from the southwest. Okay, these were coming from the southeast, so something strange. And basically, they made a lot of damages. I show you something. This is the harbor of Rapallo, where you can see the next wave is coming. So you see the wall, the breakwater, and magic, the wall is not there anymore. Okay, so then the waves become to get in the harbor. You can see on the top right, the smashed completely breakwater, and you can see the smashed yacht on the coast. Okay, and Pier Silvio Berlusconi as well lost his yacht. So basically what we should expect, because we have the sea level rise, which is bringing the waves more inland because you increase the level, so waves reach more inland. The other point is how are changing the waves in the Mediterranean Sea, because the work that I show you are related just worldwide. In the Mediterranean Sea, it's happening something strange. That means that the average energy is getting lower, okay? So you have blue. So which is why on the other ocean was getting higher and we're getting lower. Basically, the problem is that the answer, my friend, is blowing in the wind because you got stronger storms, but shorter in time, and waves are like have a bigger inertia. So the wind has not the time to transfer all the energy to the sea surface. The problem is that, for example, like in 2018, if you have a switching direction of waves, because coastal structure, coastal management is always thought to counteract the action of the waves coming from one direction, you are in big problem because all your structure, all your beaches are turning. For example, beach can experience big erosion because need to readapt themselves to the new condition. And the level that we had that days, it will be the typical level of the future. This is another simulation in which we evaluate some flooding due to a standard 50 years storm. This is a really important touristic village, little city in Liguria. Actually, when I show this to the local authorities, they want to kick me out of the room and burn the computer because you can imagine the economic value that has this simulation. So this is today. And then you make some increase, okay? Like scenario at 2050, okay? And scenario at 2100. So you get basically all the historical city that is flooded. And it's gonna flood it twice a year. So it's not, you say, sustainable to keep the city in that state. You need to do something. Then you have the problem of the management. What to do? You need to think about solution. So when I told you about the appetizer that we are getting the lunch, because if you get the history, I downloaded the last updated data, you can see the time sequence, and you can see 2020, which was a higher layer of the historical series. Then you have 2023, that was last year, in which the climate change was actually, we had you say a shot of snow, huge shot of water, after. So we began to experience, and you can see 2024, we are even. So it seems that the system just is going to another system, to another solution. So these are temperature anomaly of 2023. Basically everywhere is warmer, just some points are colder. This is globally, but this is the Mediterranean. Okay, so again, you see the statistic, and we are well above the statistic. The Mediterranean is really crucial because in terms of atmosphere and ocean, it has a lot of complex orography, so it can explode in really strong storms like Varia, okay? And basically on the left, you can see the trends of temperature growth in the Mediterranean Sea, which will results in increased level rise. Why? We don't have sea ice, we don't have ice in the Mediterranean, but the water of the ocean is expanding for thermal expansion. So if you increase the temperature, the volume increases. So you have another effect. And this is another newspaper from the beginning of this November, which coastal structure, and you will see later in the presentation of Francesco, experienced a lot of damage in the Genoa community. This was the storm, and in the same storm, I just show you what's happening on the coast of Liguria. This was the beginning of November in Camogli, a really nice place where you want to pass your holidays. Okay, so this was during one storm, and we are beginning to face this problem. Okay, so infrastructure are really exposed and the other point crucial, which is more environmental and more related to ecosystem, is that as I told you, the ocean is absorbing heat and CO2. When it does absorb CO2, it increases its acidity. When it decreases acidity, it poses a lot of problems for survival of species. especially those which needs to build shells, to build carapace, okay? Because they use the carbonate. If the ocean is acidificates, they don't find the carbonates that they need. So this is a problem that is more from an ecosystem point of view, but is connected. And I just leave you with this short movie that tells you how the project, the climate projection evolves in times in order to understand what happened between the simulation and the reality. And you see the dashed line is when the projection has been done, the continuous line at the observation. So you see the model, how to behave against the observation. So that means that basically the model get the trends and get the numbers as well. So basically what we can conclude that we can trust, not totally, but we can trust the trends. So what we need to do, these graphs, I think that you already saw them during the COVID. These were the waves of the COVID, but if you think in a climate change point of view, you can smooth out the wave if you begin to think about protective measure and mitigation measure. The thing is that you need to act now, because as I told you, it seems that 2018 was beginning to give appetizer, but we are getting the big eating now. Okay, thank you very much. Questions at the end?
Thank you, Professor Besio. And we will keep the questions at the end of the second presentation. And now we'll leave the stage to Dr. De Leo. This one.
Francesco is fine. So good evening, everyone. And well, we have just seen, don't want to spoil all the presentation. We have just seen what are the major threats for coastal areas. It was quite alarming, actually, but it's all true. And then, of course, we have seen that the major threats are related to coastal flooding, and I should add also coastal erosion, so the loss of land. Now we shift a little bit our focus, and we try to see what can we try to do to deal with these threats. What are the countermeasures that we can take to deal with these issues? With few hints about nature-based solutions as well. So when we speak about coastal defense, there are different strategies available concerning, of course, flooding and erosion. And a few strategies, a few activities concern coastal management, that is early warning system and tailored land use policies. But then most of the activities concern the proper, let's say, coastal engineering, which can be grouped in different families of, let's say, projects. The so-called hard project that concerns the construction of barriers, such as dikes of various types, so we will see a few. Soft, the so-called soft engineering countermeasures, that is nourishment or adding sand where it has been lost owing to storms, like those that we have just seen. And then the worst case scenario, which is the realignment. It means that we acknowledge, we realize that there's nothing we can do to, let's say, to face the issue of climate change related effects. And then we take our coastal assets, our coastal infrastructure, and we move them back landward. It's something they do a lot, for example, in Australia, a little bit harder in Italy, of course. But of course, the thing that is done the most is to build stuff. And it has always been so. When we speak of coastal defense, usually we speak of dikes. And in fact, there are nowadays still remains of coastal defense structures that were constructed a long time ago from the Hellenistic period. And you can see an example of a breakwater on the left side, or Roman docks built during the Roman Empire in Civile, and those are still in place. And you can see those were built with bricks. Nowadays, of course, the technology has changed, they have improved. And today, the most common types of barriers that I guess you're familiar with are the vertical breakwaters, which are made of concrete caissons, like that you can see on the left side of the slide, or the so-called rubble mound breakwaters. Those are just a collection of very big rocks, can be up to 10 tons, that are pulled together to shelter the coast from the action of environmental stressors. That is mostly waves, tides, and sea level. So these structures are very effective. They can shelter the coast indeed, in the present situation at least, because they are designed to stand some design forcing. But they come to great expense, that they have an impact on the landscape. And in fact, there's always a trade-off to be accounted for between coastal protection and landscape conservation. Here I just brought a very explaintive, I would say, example. In Liguria, nowadays it's very hard to get permission to build new dikes because the superintendenza tell you that it's going to spoil the landscape. And also for the dikes that are undergoing construction, like the new harbor dike in the port of Genoa, you cannot really, let's say, do whatever you want to, because, for example, there was the project to keep the dike with the wind turbines, and then the superintendenza said no. They wanted to electrify the dock and the berths, basically, and they say no, because it's gonna spoil the landscape. So they were not allowed to place the wind turbines, which was, in my opinion, a little bit sad. And this is for the major port breakwater. For minor, let's say, infrastructures, it's very hard to get this done. So to tackle this issue, usually, or at least there is a type of barrier which is getting very popular, and those are the submerged breakwaters. Here you can see a section. It's like the, let's say, the smaller brother of a rubble mound breakwater, because the technology is very simple, it's exactly the same, with the exception that the barrier is just placed at the sea bottom. So the idea is not to shelter, to fully shelter the coast at least, but to make the waves, the incoming waves, stumbling on the barrier so that they can lower their energy content. In this sketch here, you can see the waves that are moving from the right side of the sketch to the left side. But there is a shortcoming that in order for these structures to be effective, they need to be very wide. Here we can see a section. So the wider the section is, which will be the B ladder in this section here, and then the more efficient the barrier will be. But if you surf the net through either Google Maps, Google Earth, or Bing, or whatever you want, you name it, well, you will realize that most of the submerged breakwater, you can see the shadows in these two pictures, are very long and they're very thick. Why? Because there's, how can I say, there's a kind of misconception that you need to protect vast coastal stretches and therefore to make very elongated structures. But those are very thin because, of course, they have a cost. They're very expensive. So you need to save money, and then you make them long and you make them thin, and you think that it's going to be safe and it's going to shelter all the coastline. But it's not so. They do not really work well. So recently, let's say the coastal engineers community acknowledged that there was a problem with this type of structures, and there's another type of structure, another, let's say, another type of technology that was born in the beginning of the years 2000s, the so-called artificial surf reef, that basically changed the paradigm. The structure is much narrower, but it's much thicker. So here you can see a prototype, a very small prototype. And if we take a section, the idea is very simple, actually, and we can see it with this small animation. The waves are trying to travel along the artificial surf reef. They're pushing water over a volume that is gonna be reduced. So they get shorter, they get higher, and then definitely, ultimately, they get steeper, and so they break. That's why with the artificial surf reef, what you're trying to achieve is to make waves breaking further away from the coast so that they can dissipate their energy, not moving any sediment, not triggering any sediment transport at the coast, and not having the energy to float the coastline. So usually you have to place these guys here, these devices offshore. And here you can see an example indeed of the very same prototype placed close to the coast in this case, and you can see that the breakers occur exactly on the barrier. And the objective is twofold, actually. So you achieve coastal protection for small coastal stretches, and also you can, depending on how you design the barrier, you can rule the shape of the breakers, of the wave breakers. And so this can be, let's say, used to enhance the surfing activity, so to boost the sport and make your location more catchy. Well, here you can see another example of artificial surf reef. All these studies were developed in Australia and New Zealand. No surprise, because like the surf is super popular. But now they are trying, and we are trying at the University of Genoa to deepen some studies and try to replicate those type of structures also in Liguria, along the Liguria coastline. Giovanni already mentioned the Stuola beach, and that's where we are working now, which is, I think, is the biggest beach in the urban area of the Genoa, on the east side of the Genoa city. Here you can see a picture of it, maybe. And there are a lot of facilities that are constructed and placed directly onshore. And so all those facilities suffer from periodic floodings and loss of land owing to the sea storms. And here you can see an example. Look, the picture that you see on the left side refers exactly, I don't know if you can see my cursor. Yes, you do. So this picture here refers to this facility. This is La Sportiva, where there's a swimming pool basically that is periodically being flooded because of waves that are breaking directly onshore. So the idea is to protect this beach, and to achieve this goal in 2020, a group of people, both citizens that were keen on the Stuola beach and stakeholders, local stakeholders like those that own those facilities, formed a consortium, which is called GOA, Genoa Ocean Coral, trying to come up with ideas, new ideas to protect the coast and also to make, let's say, the Stuola beach more, let's say, catcher, not only for sunbathing, basically, but also for the practical sports that could allow to use, make use and leverage the beach during the winter time and not only during summertime. So here you can see a few steps of between, let's say, from 2020 when the consortium was formed up to 2023, when they get it approved, the project by the Genoa municipality, and we were involved by this consortium to try to design an artificial surf reef to enhance the protection of the Stuola beach, which we did. First, through sampling and equipping we are still in, let's say, in the loop, in the process of equipping the Stuola beach with the devices to measure the sea and measure how the barrier will be effective. For example, through a buoy to measure waves, and then an acoustic Doppler current profiler that allow to measure the currents. And then, and this is very cool, I really like this app, which is called CoastNap, which is simply an application, a suite of codes, MATLAB codes, that allow you to process smartphone pictures that are taken from a fixed metal cradle, like that you can see in panel with labeled with the letter A. So we place a cradle like that. Everyone who wants to help us with the research can take a picture, which will be processed, and will give you back the position of the coastline so that we can track how it moves back and forth in time. And so we did some analysis about how effective could an artificial surf reef be in the Stuola beach. We made use of a student, as you can see, to work with Giovanni. Besio is not very hard, because this was part of a bachelor thesis, Thomas Alfonso thesis. Part of the thesis was to first to take some measures to reconstruct the geometry of the Stuola beach. And so to measure the elevation, the bathymetry of the sea bottom, as to allow us to make some analysis, some simulation, and see if the beach will be flooded under severe or mild wave condition, for example. And there you can see the result of the survey, the digital elevation model. We did some analysis with this, with some, going into the details, some numerical models. And what you can see is a comparison of exactly the same situation. So exactly the same wave forcing, but in the upper panel, you have the current profile of the Stulas Beach, that is a transect across shore section. In the lower profile, you see that the sea bottom has been modified as to account for the artificial surf reef. And if you focus on the upper part of the beach, which is where the shoreline is basically and all the facilities are, what you see is that in the first case, you get flooding, but in the second one, you do not. So apparently it will work. Of course, these are preliminary results, but they're pretty encouraging. And now you may wonder about how can this be associated to nature-based solutions? Because in fact, it's like human-made, basically, barrier. Well, the fact is that you can construct these barriers, these devices, with blocks that are designed as to enhance, as to boost the growth of marine vegetation, and as to ease up the nesting of fishes. And I'm speaking of the artificial reefs. These are man-made blocks that are constructed with a cement which is non-toxic and allows for the growth of algae and for fishes to repair and to nest. And you can see a couple of examples here, a couple of pictures of one of the most popular artificial reef, which are called reef ball, that of course achieves a variety of purposes because you get environmental restoration, and then you can of course trigger tourism because those are, you will see there are shapes that are very beautiful, very pleasant, and so you can enhance diving activities or diving activities, for example. And then coastal protection, I just put a question mark because of course you achieve coastal protection if you properly design the reefs, if you embed those reefs in coastal defense infrastructures as those that I was mentioning before, which we are planning to do in Stuart. Then you can see there are like many different shapes of artificial reef. Well, this third one is in Indonesia, and I don't know why, but in Jordan they thought it would be a good idea to sink a war tank, and they call it reef. I don't know if it is really effective and if it is non-toxic, but it is what it is. We were lucky enough to design our own reef. I'm gonna give you a brief example in the framework of the Natural Bania project, where we were involved along with the University of Trento. We were part of the so-called Blue Coalition, and the main objective was to support sustainable development of coastal areas. And we worked in particular in the Porto Palermo Bay, which is in the south of Albania, close to the border with Greece, which is a lovely place, very beautiful. If you have the chance to go there, please do. But there's a huge problem because all the seagrass meadow that were there, let's say, were wrecked by uncontrolled fishing activities with bombs even and with nets mostly. There are not really regulation, or if they are there, there's no one that can really, let's say, make sure that those are the requirements are met. So one idea that we got to try to restore a little bit the marine environment was exactly to design the reef, which we did. And these are the reefs that you can see we designed and we constructed with a company in Pisa, which is called D-Shape. And we installed in the bay. In this video, you see the reef that were delivered. They were shipped to Albania from Pisa, basically, and then leveraging a crane, we placed those in the water, and then we moved them to the target locations. And here in the lower left side of the slide, you can see one of those reefs that were installed. So reefs are, in fact, part of the so-called nature-based solutions, and I'm gonna end this presentation showing a little more examples about this, because sand nourishment themselves can be thought of as nature-based solution. Because usually what they do, in Liguria they do that a lot, also along the Adriatic Sea, is to take sand from the offshore areas and to place them on shore as to make the beach wider for touristic purposes, of course. But doing so, you make sure that the texture, the grain size distribution is totally consistent to the native material. So you're not adding something new, something different that might spoil, let's say, the ecosystem and the landscape. There are different technologies to do so. The problem is that, of course, if you have a beach that is undergoing erosion, either owing to climate change effects or because of improper coastal defense projects, you need to do this every year. And this is very expensive. And then, speaking of nature-based solution, we cannot neglect the seagrass meadows. Why? Because there's like a huge variety of benefits that are brought by seagrass meadows. That will be Posidonia oceanica. That are the most common, it is the most common, let's say, type of vegetation that you usually find in our seas, basically. And you can see that it enhances the mixing of water. It allows for energy dissipation by waves, mild waves, we should say. And then it enhances the uptake of carbon dioxide. But mostly it forms a barrier. You can see here in the lower right side of the slide that it stabilizes sediments. So the sediments that are moved from the action of waves, basically on the bottom, are sheltered by the roots and by the leaves of the Posidonia oceanica. So at least you do not get that type of erosion on the bottom of the sea. But in case of very huge storms. Giovanni mentioned the 2018 storms that destroyed a lot of ecosystem in the North Tyrrhenian Sea along the Ligurian coastline. You can see here a research from 2020. In the area of Rapallo, you saw the dike of Rapallo that was destroyed by the action of waves, but also below the water, there were huge problems because all the Posidonia oceanica that could be found in the marine protected area of Portofino was partially destroyed by the action of waves because the energy was too high, was too intense. So imagine how critical would be the situation if those type of storms would get more frequent by the years, which apparently is the situation we are going toward. And here you can see on the right side of the slide a couple of pictures that were taken right after the storms and where there's almost nothing left of all the Posidonia oceanica that was there. So this concerns the degradation of seagrass meadows, but then of course, luckily, we can also try to do some restoration. And this is taken from another research, still from 2020, and it is pure chance because it's completely another place in the world. This is the Virginia Bay, so we are in the North Atlantic side of the United States. And you can see the evolution from the Posidonia oceanica that was in there from 2001 up to 2018 on the right side. The green areas are those with the new plants of Posidonia oceanica that were put there by a team of researchers. And while they were planting the new seagrass meadows, they were also surveying some flags, let's say, parameters related to the wealth, not to the wealth, to the health of the marine environments, which bring me to the conclusion of the presentation. You can see how many benefits these yielded in terms of net carbon stock, in terms of invertebrate biomass and also fish biomass that increased through the past 20 years thanks to these new seagrass meadows. That, of course, are fully nature-based solutions that can be used to restore the marine environment. Now there's a little bit of, let's say, it's a bit misleading to think that they can be used also to shelter themselves, the coast, from erosion. But if they are coupled with countermeasures that are aimed at, let's say, preserving the coast from being eroded, of course, those are the way to go to get a win-win situation, which you try to protect the coast and also to restore the environment that has been degraded. Thank you.
Thank you, Francesco, for your presentation. I think we have a broad picture both on processes and applications. And thank you. It was super interesting. If you have any questions, both here in the room or online, please feel free. Just for the question here, please come here so also the online audience can hear that.
Well, of course, nobody will buy a house in 2 lines, right?
No.
After this talk,
Giovanni, Francesco, thanks for your presentation. It was very nice. And the question is this one. So, who present a situation which is very, say, I'm very worried about that. You know? And then you are saying essentially that we can, so we have a problem with the cost very big, and then we can solve the problem with infrastructures that cannot be built everywhere. So we have to decide what we can save and what not. I would like that you comment on that. I know that you present something also on nature-based solution, but yeah, I think that also in this case you so you have to decide, you know, and then where to take actions. And yeah,
I think that it's a good question because it doesn't have an answer. So you can work on it for how long you want, and basically it's a political issue. So it's a matter of decision, of choices. Technically, you know everything. You can make projection, evaluation of impacts, and so on. But basically, it's a political decision. So we need to keep them. I give you an example, which is really clear. In our region, after the storm, basically they call the calamity state. They got calls money from the government, and they reconstruct everything that was touched by the storm. But it was something like 350 million of euros, just to give you numbers. Okay, this is okay, but if it's going to happen every 5 years, is it sustainable or not? So I mean, the thing is, coastal is really complex because every trait is different from the other one because of morphology, because of forcing and so on. So you need to tailor something. But then you need to make a decision. So there are some experiments, like in Spain, they made what is called a retreat. That means they abandon a really long stretch of coast and just give it back to nature. You can do it. For example, in Liguria, you have built everything from the French border up to Tuscany. So it's a huge problem.
Also France, no?
Less. Because they have more space.
Another question.
Don't be shy.
You got from you for the presentation, very quick and effective. I'm afraid that there's another wave, huge wave, the flow back from the policy in mitigation, adaptation, and other strategies in facing and dealing with the climate change. For instance, when we are speaking about natural restoration and ecosystem restoration in the coastal marine areas, we are thinking of the failure of the policies. Two days ago, we stopped the Natural Restoration Act in Brussels. And while the Global Biodiversity Framework is calling up to the 30 by 30 strategy, restoring 30% of ecosystems by 2030. Impossible to do it. My question is, what about the urban planning as an ally to combine specific techniques of intervention, punctual sites, specific places. Very curious to get in depth with the solution we were suggesting, especially in terms of artificial reefs, etc. But I am curious to know your opinion about the urban planning. What is the future of urban planning, especially in Italy, in replacing the settlements, coastal settlements, due to the impossibility to deal with all the huge future in terms of waves and storms and other climate change. Thank you.
I give an answer, then I give you the next question. Basically, I experienced a really nice and virtual case, which is on the Adriatic coast. I will not say the local community, but basically they made what I think that it should be made. So they made a plan of vulnerability of their asset along the coast, and they made the according to this vulnerability. So the area with really high coastal vulnerability, they just put some incentives to demolish structure and asset and to release, and they gave an added value of square meter, cubic meter on the backside of the local community. And they got a lot of application because, for example, some enterprises found an opportunity to have more space, to have a more secure situation, to don't spend money in protection. And so they made free some area of possible future impact. So this, I think, this is a virtual case that when I heard about them, I told them that I really liked it because it's the way. We have an issue because you can do it on the Adriatic coast of Romagna. If you come in Liguria, you can tell them to demolish, but then when they ask you for space, you say there is no space. So it's a problem of local situation, but actually it's crucial because, as I told before, we as technicians, we can give you all the possible impacts, projection, whatever you want. But then who needs to put them on the ground is the political, which is the piano urbanistico comunale or regionale.
This is why I think that we can improve our way of building up the urban planning and land planning by adding vulnerability maps. The process of national mapping, as you know, in coastal vulnerability is in progress, but is still not applied at the local level in the municipalities, I mean. So I think
and
that
it is not, as you say, when you give constriction. It's not factual that you can say you can beat the regional coastal plan, but then it doesn't have restriction. While on the rivers it does.
Yeah. Adding, of course, enforcement. Otherwise, the simple mapping procedure is not sufficient. Okay, sorry for interrupting.
No, I just wanted to add, because perhaps I wasn't clear enough during the presentation, but as an order of magnitude, so how wide it is an artificial surf reef, the one that we try to design in Stola, it's roughly maybe in between 50 to 100 meters. So it is effective, but for a very small coastal stretch. Of course, the Liguria coastline is much longer than that, but we cannot place reefs everywhere. So it's crucial exactly to spot the location where it makes sense to try to protect the facilities and the assets, and where it does not. But I wasn't born in Liguria, and I don't find the Ligurian people very willing to leave their belongings on the coast. Sorry for that line.
Thanks for the presentation. First of all, just a quick one, maybe off topic as well. How about wave energy converters? What's the state of the art, and do they have a potential also for coastal protection in that sense?
Well, the quick answer is that for coastal protection, perhaps not that much. There are a few examples, few studies that concerns the offshore wind turbines. So there are very wide piles, and then they can have an effect. They can shelter actually the coast. But as for wave energy converters, they are much smaller. So nowadays we are more in the process of trying to make them work in terms of energy production and not other, let's say, side effects, although they would be greatly beneficial. Correct me if I'm wrong.
Yeah. Okay. The stage of the research, we are. Do you know what is TRL?
Yeah.
Okay. So basically, wave energy is TRL from 3 to 6 maximum. So we are well behind because it's the typical growth scale of this kind of tools. The point is, wave energy is huge because basically, if you just make a factor, you have the density of water. So, and just to give you some figures, for example, if you can exploit all the energy along the coast of Chile, you can just feed up all the southern portion of United States energy consumption. So it's huge. The problem is that you still don't have the technologies. And the other problem is that you need to put them in a really harsh environment. So it costs. So do you know what is the levelized cost of energy? Yes, no? Okay, so basically it's how much you pay to produce 1 megawatt. So basically with I think that natural gas is around $10, $15. Now wave energy is like $200. So it's out of the market. So you need to push it in order that it gets you lower down. If you check the charts of the levelized cost of energy, you see, for example, solar panel 10 years ago were completely out of the market. Now is the cheapest source of the renewable energy. So what they need is to find the device, the situation in order to optimize this development. It's really promising. There is few stuff. Actually, European Union is investing a lot. Last year, they financed 2 strategic projects for pilot site, and they were both of them like 30 million euros. So they are not. And for example, in Liguria, we are writing with the Regione Liguria project on this because we would like that the Sturla open level will become a pilot site for wave energy converters. Because for the other thing that is misunderstood is that if I want to produce wave energy, I need to go where I have huge waves. This is not true because basically it increases the cost because you need to resist more force. Sometimes mild energy seas like the Mediterranean or the Caribbean are really good because you don't have big streams, but you have energy. So maybe it's a promising side as well.
He was asking about if they can be used for coastal protection, but I'd say no.
For coastal protection, really no, because basically then you have an environmental problem. If you stop completely the waves, you have stagnant water. If you have stagnant water, you basically, if you go to the Adriatic Sea, that for us Ligurian is not a sea, basically you can experience the effect of what is stagnant water. Eutrophication and so on.
I'm from that area. Well done. I wouldn't recommend it. Thanks.
Don't be shy if you have any kind of question. If you are not familiar with the subject, it's okay.
No, that's in the chat. I said no. No, okay.
No bother.
Thank you for your presentation. And you mentioned the fear of the municipality when you presented data about floods in the coast. So I wanted to ask, how should science be communicated and to who to be effective? It's maybe out of topic, but not so much.
No, this is not off topic. It's really interesting question, and again, I don't have an answer because it's really difficult. Because then that is the usual problem that the management is a political issue. The political issue has a really short term. So basically, you need to give solution for the short term, which a lot of time they are not the really good ones. We didn't show, but for example, in the Netherlands, they made a huge project of a renourishment of a stretch of coast in which they made a huge nourishment. That means they moved millions of cubic meters. Why? Because usually you do the nourishment every year. So you lose 5 meters of beach, you put them back, and so on. The thought was, every time you do this, you completely kill everything that is on the way. You kill where you take the sand, where you put the sand. So they thought, just make something which is 50 years, more or less, to the time framework. So doing this, they made a huge intervention that is lasting and it's working. But the problem is that if you do it, then you will not cash up politically this time. Okay, so it's really difficult to put on virtuosity in this kind of decision process. Actually, in that case, we spoke with the management of the city and basically we told them solutions. There was a corporation that was against the solution that we were proposing, and we won the corporation. So the local community would make what the corporation wanted, not what the technician suggests. So I think that it's a long way, maybe infinite.
And they were not technicians, by the way, those who didn't want them.
It was a corporation, not of technician. Okay.
Because I'm from Genoa as well. So we studied together with Giovanni, the PhD together in Genoa. I come from there, so I know that there is a new dam which is going to be built in Genoa. I was wondering if they, if all the climatic scenario have been taken into account in the design of the new dam.
Yes, they have been taken into account because I will break a spear for the designer because they were good designers, so they knew that they had to take into account. In Italy, it's not compulsory. For example, in the northern countries, you need to design all the coastal infrastructure with a projection at 2100. So level of the sea, wave condition, you need to use the projected value. In Italy, this is not written anywhere, so it's up to the consciousness of the design. But basically, I would say that for the breakwater of Genoa has a little impact, because the things that you have, that you can have some impact are minor, related to coastal management, which is much more, how do you say, complex. Paradoxically, in adverse situation, if you have sea level increase, sea level rise, it's a bonus that you have because you gain depth that usually you need to bridge, so you save money. So port authorities are sponsor of the sea level rise.
And among the effects that you mentioned, from a physical point of view, you mentioned the sea level rise, and at some point you touch the ice melt from. So this will induce also change in salinity, and then a change in, say, currents, density currents.
Okay, I'm not an expert on this because I'm not an ocean climatologist, but for sure. I just came out 2 words that really working. That I don't know if you know this about, but basically they have measures that the Gulf Stream is decreasing. And basically, if the Gulf Stream is decreasing and shut down, so you have a complete change in water climate. Actually, there is a really nice movie telling what is going to happen. Did you see it? The day after tomorrow. You can watch it because it's happening. There are 2 words, one in 2023, one in 2024, that are found on the measures what the day after tomorrow was saying like 12 years ago.
Thank you very much.
If there is something that I would like to add, because we spoke a lot about extreme events, but there are places in the world where like climate change effects are already being visible. For example, in the Biscayne Bay, which is where the city of Miami is, roughly twice per month, they have to close the streets to the traffic because of the high, what they call the muson flooding. They have a tidal excursion, which is very mild, is about 60 centimeters, so it's not that much. But since the sea level there is increasing so fast, that is enough to partially flood the urban area of the downtown area of Miami. So there it's really critical because it means that roughly every 2 weeks, you have to close part of the suburbs of the city because of the flooding. So perhaps we are not really concerned about this because in the Mediterranean Sea, we see these events once in a while. They're associated to the extreme conditions. But there are places where this is not, but this is already being critical, and it is like all day situation, almost all day situations. So we surely start thinking about this, I think.
I have a question going back to communities. So you presented the situation and the dialogue with Ligurian authorities. What was the case of Albania in the installation of the artificial reefs? And what's your comment about the relevance of each context in the design also of the communication among technicians and administrators?
Well, let's say that the hardest part of the installation of the artificial reefs in Albania was not related to the design of the reef and, let's say, the computation to make sure that it will be in place and not drifted away by the currents. So the technical aspect was rather smooth compared to the administrative part, because it was very hard to understand who was in charge, which authority was in charge of giving us the permission to go ahead with the project. So initially we spoke with a guy from the municipality of Imara, which is the town nearby Porto Palermo Bay, and he said, you need to go to the minister. So we went to the minister and they said, you need to go to the Environmental Protection Agency. Then we went to the Environmental Protection Agency and they said, you need to talk with the municipality. And we were quite disappointed. We were struggling a lot, but then luckily, eventually, I don't remember who passed Millero, so because we were working with the Agenzia Italiana Cooperazione allo Sviluppo, and they helped us a lot with all the paperwork, and somehow, but it took like a really long time to get the reef installed there, and it was due to administrative, let's say, difficulties, which is not something that is a concern only for Albania, because just to give you this news, it's been 3 months now that we are trying to construct a very simple metal cradle to get COSNAP working in Sturla, and it's really hard because we need to get the permission by the municipality. We need to get the permission to build the structure with the funds of the university. So one thing that might be 2 hours of work for a technician is taking 3 months for us to get it constructed and to put it in place. So but we don't need to drop it. So we will still try to get this done, and we will anytime soon, hopefully.
No more curiosities? You have some time if you want.
The last opportunity.
Let's say no.
Let's say no. Okay. Well, I would like to thank you, Giovanni and Francesco, because they left Genoa this morning to come here for the seminar. So it was quite a long trip.
We brought a lot of rain.
Yeah. But it's okay. We need it. And it was super interesting, also because we don't have the chance to see maritime and coastal stuff very often. And I'm always super happy to learn about it. All the slides and the material will be uploaded in the online platform. So everything will be available for you for the final exam. Just a final logistic remark. I don't know, but you should have received an email with the proposal date for the final exam for the ones who needs the credit recognition. That is the 10th of June. If you have any overlapping with our other exam, just let me know, and we will try to schedule another date with Professor Zalezzi. In the next month, we're not going to have any seminar of the series. We will go back to ESIC seminar in May, okay, with the last two. And that's it from my side. I don't know if I forgot something. No? Okay, thank you.
Thank you.